Hi there, and welcome back to Basic Math for Economics. In this video, I want to take another look at unconstrained optimization, but now I want to deal with multiple variables. So we're going to do an example with a Cournot duopoly, which I have right here. So setting this up, we're going to have two firms that are competing against each other in quantities. And they're both going to face the inverse demand function of A minus BQ1 minus BQ2, where Q1 and Q2 are firm 1 and 2's quantities. They're both also going to face a constant marginal cost of C. So let's set this up, and let's actually start with firm 1's maximization problem. So again, their goal is to maximize their profits, so I'm going to write max, and the only thing they have control of is their own quantity, so their only choice variable is Q1. So they're trying to maximize their profits, which they get their total revenue is going to be the inverse demand function, which is a function of their own quantity and their competitor's quantity times their quantity, so there's their total revenue, minus their total cost, which is just going to be CQ1 in this situation. So this is our objective function for them. It only has one choice variable, so I only need to calculate one first order condition. So I can get the derivative of firm 1's profits with respect to their quantity, and that's just going to be A minus 2BQ1 minus BQ2 minus C, and then I'll set it equal to 0. Now I can do the same thing. I can set this up for firm 2. So they are going to maximize their profits. Their only choice variable is their quantity, and again, they're going to face the same inverse demand function, and it's going to be multiplied by their quantity because they're interested in their own total revenue minus their total costs. And again, I have an objective function. I have one choice variable that gives me one first order condition. So the derivative of their profit function with respect to their quantity is going to be A minus BQ1 minus 2BQ2 minus C, and we'll set it equal to 0. Again, that's my maximization condition right there. So what I have now is I have two equations and I have two unknowns, and I can solve these out to get my equilibrium. But let's actually have a little fun with this. So if you'll notice, these firms are symmetric. I can rearrange the subscripts for firm 1 and firm 2, and I can get from one first order condition to another first order condition. So rather than going through and doing a whole bunch of algebra, which, it's doable, there's nothing wrong with doing the algebra right here, let's instead invoke symmetry, because we have all of the requirements for that. We have symmetric first order conditions, and we've already taken first order conditions. Remember that we never invoke symmetry until after we get our first order conditions. So I'm going to assume that since these firms are identical, they're going to produce identical quantities. So I'm going to say that Q1 equals Q2 equals Q. And what I can do is make this substitution into either of these first order conditions, and they're both going to reduce to the same thing. So let's do this first one right here. I'm going to get A minus 2BQ minus BQ, I'm just dropping all the subscripts right here, minus C equals 0. Well, let's clean this up. Everything with a Q goes to one side. Let me scroll this up a little bit. Everything with Q goes to one side of the equation. Everything without a Q goes to the other. So combining these two terms, I have 3BQ, and on the other side, I have A minus C. Well, I can divide both sides by 3b, and I get Q star is equal to A minus C over 3b. And that's it right there. That's my equilibrium quantity, because that, move up a little bit more, is also equal to Q1 star, which is also equal to Q2 star. So this is really great. I can go through and I can invoke symmetry to make this analysis much quicker and much easier, to be honest. But again, remember the rules of invoking symmetry. We need to have a situation where we have firms that have symmetric first order conditions. Basically, I need to be able to take all of my subscripts, switch the 1's to 2's in this cases, and get the other first order condition. That's the first requirement. The second requirement is that I have to make sure I do it after I take the first order condition. When both of those things hold, we are able to invoke symmetry and greatly ease the analysis of this problem. So anyways, that's all for this video, and thanks for watching.